Yo, welcome back. This is your advanced tutorial on Visual Studio on the UI and layout. So I want to only cover the stuff that you're going to be particularly using in advanced stuff. I'm not going to get into all these little extra small good features. You can look up on those on your own. So let's go ahead and get to it. So the first thing I want to discuss is let's start with breakpoints. So if I want a breakpoint at this position here, what I'm going to do is I'm going to right click where I highlighted and I'm going to insert a breakpoint. So when I debug this application, it's going to stop right here, and this is going to give me a diagnostic tools. It's going to tell me how much process memory that I'm using, so how much RAM I'm accessing. But for this application, it's going to tell me the CPU percent of all processors, and I can even record a CPU profile if I choose to want to know more about what's going on. Now, if I can go to tools, and there's a thing where you can also go here and you can add a different theme here to the whole application. If you want to do that, you can. You can get more themes. You can look that up yourself. That'd be more easier. If you have a question about it, I can definitely just kind of show you as a special video or tell you how to do it. But other than that, if you go back let's actually go to here and go to Windows. And I want to show you something called a disassembly. Now we're able to see the disassembly, the x86 assembly of the actual application we're on a breakpoint on or debugging. And this is machine language, sort of to a point, but we're using x86 assembly for more human readable output. And if you notice where we kind of stop here, and that's where if you look, we highlight it main CPP line 6, which is line 6 where we breakpointed. And we're able to see that we're calling a string hello CPU. So anyway, and if we go here, which I've already done it, but you can go back to the debug. You can go down if you want to know the registers of this x64 architecture. You can look. These are our registers: REX, RBX, RCX, RDX, RSI, RDI, different stuff like that. For reverse engineering those and most more and all this is going to be extremely important in the near future. But for certain particular things, you don't need to know unless you're just wanting to know. You can also go to performance profile, which will help you say you have specific points in your code. You can either create a timer and performance tools for within your application to help you kind of narrow down, say a function is taking too many seconds to execute and you want to kind of speed up and optimize your game or your application or your engine to be more faster, more fluid, then that's something that you can do. But this will help you kind of understand it and help you find places that are bad without needing to code tools inside your application or engine yourself. But that's a lot more reliable to do it inside the engine and create the tools there. You can see the processes. So right now this is our process. Now if we want to go to autos, if you notice, here's our registers based off of our autos. Let's see. Okay, now your threads. If we go to here, if I'm not mistaken, and we can go to threads, and that'll be able to give us our thread, or we can see a call stack on what's on line 6, or we can see and go by category, so we can set the group, or we can set the columns, enable certain columns, and we're able to see the priority, the affinity mask, the processor name, which is a project2.executable with an ID of 6788, or we can do the transfer qualifier. All that is just think of it as your device name. It's just your computer's name, so to speak, the device computer name. And we can go up here and we can set this to, I'm not even going to tell you nothing about that, just don't even worry about that. If you go to debug, again, you can do there's all kinds of different things that you can go on here. You can see the memory of whatever. Now if you want to actually jump forward into the code, you can do a step over And if we actually close the disassembly, if you watch, I'm going to go a line down. So I'm going to go to line 7. So here's line 7. Now it's going on through, and then we'll go on step down till the end of the application, and that's where we get this. Now if you notice, we're pushing 898 kilobytes of our process memory, and we're noticing we're barely peaking anything on the CPU itself, so it's not even hardly taking enough to even get the CPU moving. But that gives us a little information. So say you are dynamically allocating some memory onto the stack or on the heap, some similar. That is a major thing right there. I hardly ever use allocation unless I just have to. It's using allocation. I can allocate enough memory to be able to store data from an archive after I've decoded it and learned its compression algorithm and want to dump its asset data. I can allocate enough memory and create a base file to dump that data into that then I can use as, with an extension that's accessible through like WinRAR or whatever that particularly may be, to learn and get all asset data out of those, game archives. That's a good way of using memory allocation, but you're taking it from your RAM. So just remember that. Your application is using so much of your onboard memory as well. So just remember that, just because we're taking so much of this whole application, the more extensive we get in, the more code we have, the more lines of code, the more stuff that's going on, the more projects in the solution. Everything can alter how much memory we're using and how much hard drive space we're using or SSD space we're using, which is solid state drive, or just anything in that, or .m2 slot, which is just a micro SSD. I look at it as. Some people would argue with that statement, but that's, my point of view. Care less. But if you're curious, if you remember when I talked about that, why is it giving you that right close to that? What we can do is do a /n for a new line. So if we just go ahead and debug this, you can actually see now that where are you? There you are. I still have a breakpoint set. Let's go ahead and remove that breakpoint, and let's go ahead and continue the application here. If you notice, hello CPU now, and then there's a press key below that. So it goes, it indents a space, I'm assuming, and then kind of makes a new line. In other words, it just makes a new line, puts the other string below. You get it, get the point. And then we can hit enter to exit, or we can just hit the X key on that. Now after that, you can change the architecture space. So let's say, for example, I want to change this to let's go to configuration manager, and I have my project here. I want to set this to release, and I want to also set this, usually they allowed you to set it to both, but which is strange. Maybe that's something different now, I don't know, but you can set it to release. Now, one thing about release is we want to clean the solution, and we want to rebuild it based off of that. That's going to help us. Now, release build is more optimized, and your applications or engine or game is going to run quicker. It's going to be more optimized for release. Debug is not going to be. It's going to be a quarter of the speed dumped down, or even half the speed. Depends on how much is going on in your engine or what it's having to do from the tasks, from the event scheduling and different things like that, and how many functions you have, and your architecture is one thing. You got to remember, you're building a game or an engine or an application, but most of the people have different types of architecture. So they may not be fortunate as you to have a really nice i7 CPU quad core. They may have an old Intel Xeon or something, just an older versions of stuff. They might not have an RTX card. They might just have something simple like a 650 Ti from GeForce. Who knows what they may have? They may only have 6 gigs of DDR4 memory. Everybody has different hardware specs. So you have to, when you're building something, you have to base your game or your engine or whatever around all these other specs and all these other architectures. Especially if you're building for multiple different platforms like Linux, maybe Android, iOS, or Windows, or Mac, or let's say you're building for, what I meant by iOS is a phone. you could either be building for the PS4, the PS5, the original Xbox, or the PS2. Who knows what you're building for? You just got to be able to, that code has to be optimized for all these other platforms. So it's really, really difficult. So that's why exclusives are more easier, because the game was built for that one specific architecture, and it does a good performance job on that. And it's quicker, make money, they get it out the door, and they could care less. And that's just the way it works. So that's pretty much some advancements in here that I just wanted to cover with you. I don't want to cover anything else because everything else is pretty self-explanatory. You can save one file or save all, or you can close the solution and you can clone a repository. So say, for example, I have an add a source control and I had a repo on GitHub on my account. I had to sign in and go to my GitHub, and I clone this repo, or I create a repo, particularly here if I'm not mistaken, and every time that I do a code change, I can push everything here. It'll go directly to my repo on GitHub instead of having to launch the GitHub desktop client and then push my code and pull over from the source explorer and all this bullshit, or go on the website and be limited to how many file size and how many files you can, or blah, blah, blah. It's really simple just to push everything right here inside Visual Studio, and you're damn good to go, right? So that's really good, neat trick there that you can use. And you can go to recent files, recent projects and solutions. You can hit save all here. You can add a new project to this existing solution. So if you want to have multiple projects in here, you can right click on the solution. You can click add a new project, and let's say, for example, I want to just make this project right here my particular set as startup project. So this is the one that's always going to compile first before the rest on below it. Or if I have multiple projects and I just want to debug just this one, I can right click and just debug just that project alone. If I hit this or right click and hit debug, if I just hit this, it'll debug everything. But if I right click the project and go here to debug and hit this, it'll debug that. Or I can do the same here with the solution, where I can build the whole solution and just build the entire thing and then debug it all. It's particularly debug as it's building and debugging at the same time, if I'm not mistaken, or one from the other. Either way, you get the point. So I just wanted to help you out on that, give you some advanced features. Down here, you've got your output from the build and the build order, and you've also got your errors that can be printed here. So say, for example, I have an error here, and I go to save it, and then I go to right click and build it. And let's say, for example, I have one error. I can actually go and click this and see the error in more depth. You can see the warnings and the messages, and it says here the identifier RNITF is undefined, so this function or this statement is undefined. And it's saying that also it can't find an identifier for this. Well, I've just messed up, and I just should have put a printf in there. And here we go. And this will probably go ahead and clear, so when I hit save and I build, it's going to go ahead and be just fine. I'm not going to get any issues found. The compile, it runs successful, 0 failed, 0 up to date, and 0 skip. Now, there's a chance that if I have multiple projects and I compile one specific project or all of them, and I only made code changes to the project 2, and I have project 3, 4, and 5, well, project 3, 4, and 5 will be the ones that'll be up to date and will be skipped, and only the one that I made code changes to will be the one that compiled. So one out of something compiled successfully, the other 4 is up to date, and they were skipped. So they didn't need anything recompilation done to them because those other projects didn't have code changes. Only the project 2 did at the current time of the compilation of my input based off of that. So there you go. So that's pretty much that simple. You can go down here and go to class views. You can see a class view of the global functions and variables. You can go to property manager. You can go to git changes. So if I had a git repository here, I can see the git changes and see that. I can get an error list here if I wanted to just click this or go to the output. I can see both of these. I usually like to just go from the one and the other. It doesn't really matter. Go back to the solution explorer and I can see this in depth. Now references are real cool because references, if I had a DLL reference, if I had code in a project from a DLL and I wanted to use that code in this project application to alter the mechanics, I can right click and add a reference and go basically to the projects, or I could go and browse for it, particularly if it had the option here. I can look at the internal dependencies, so I can edit the new config, edit the internal dependency, or just think of it as the libraries and all of their header files that are stored within each library. But I can see everything that is being called and utilized or being used. Resources are like if I want to alter the way an icon or a font size or the way this works, I can create a resource file for that, and you know what header and source files are. So anyway, that's pretty much it. That's all I really want to give you right now. If you build an application or something like that, it can be different because you have a toolbox for that and widgets, but you can get your notifications here. It just says that there's an update that I can go ahead and grab, so update on close. So if I want to update everything after I close this, I can, and it'll go ahead and update it for me. So anyway, that's it pretty much on the advanced stuff that you'll most likely be wanting to use in your later time. And there's some other things that are irrelevant that most likely we never talk about or use. So anyway, thanks for watching, man. Hope this helped you out on the advanced tutorial. And the next one is the big one. We're going to be working on reverse engineering the model files and converting them to objective, or whichever the PlayStation 1's models extension is. And we'll be able to show you how the process does with that. And that's where it's going to get really tricky, and it's going to probably freak you out. So if you want to watch this for fun, you can, or if you want to try it out, you're welcome to it. So anyway, thanks for watching, man, and I'll see you in the next tutorial.